Hello everyone, my name is Dominic Koh and this is my presentation on the Physics 2 Lab 1 Charge Tape Lab. So first, an introduction. Our objectives for this lab were to investigate the interactions between two charged pieces of Scotch tape, then use a glow script model, use glow script to model the interactions, then estimate the charge of the tape and calculate whether there was a surplus or a deficit of electrons. It was also important to examine how charged tape interacts with different objects. In the case of this lab, a hand, a book, another piece of tape, and a plastic pen. Some fundamental things to understand this lab is that objects can either accumulate excess or experience a shortage of negative charge when they're rubber separated. Using approximations of atoms can be used to calculate if there was a surplus or a deficit of electrons. And we calculated this on a per atom basis for the tape. Some important equations are gravitational force, the force of gravity, which is in vector format, then negative mass times gravity, and Coulomb's law, and the electric field equation, and the electric force equation. So our results, we found that the charge equals 1.4 times e to the times 10 to the negative 8 coulombs. It was also found that the number of deficient electrons is 8.75 times 10 to the 10th electrons. And we also calculated that the number of atoms per piece of tape was 4.67 times 10 to the 6. So in the experimentation, we observed that we have a surroundings and a system where everything in the room are the surroundings and tape A and B are the system. The U-tape was made by folding the tape slightly on one side so it'd be held with a charge. Have another piece of tape approximately the same length and stick it to a flat surface, then placing the U-tape on top of the flat tape and quickly pulling it off. From this lab, we expect to be attraction between the tape and the hand, repulsion between the two U-tapes, attraction between the U-tape and the book, and also attractive between the U-tape and the pen, and repulsion between the suspended U-tape and the U-tape underneath. It was noticed that two charged tapes repel each other and that one of the charged tapes attracted neutral objects. The U-tape was attracted towards the negatively charged pen, and it was determined that the tape was positively charged and hence lost electrons during the charging process. In our calculations, our tape mass was 0.2 grams, our length was 0.2, and our width was 0.02 meters. And between the tapes, we had they were separated by about 3 millimeters. The force due to gravity was 0.00196 newtons. And using Coulomb's law, we were able to find the force between the two tapes, and we were able to find the charge, or Q equals 1.4 times 10 to the negative 9. Also, we found that the deficiency was 8.7 times 10 to the 9 electrons, and using the number of to find the number of atoms on the tape, we just took the area of the tape and divided it by the area of the atom, which would get us 4 times 10 to the 17th. the ratio between the deficient charges and the number of atoms is about 1 electron every 4.6 times 10 to the 7th atoms. Here's our glow script model, and from this we calculate that the charge of tape was 1.4 times 10 to the negative 8. So some possible sources of error is that was deviation from the point charge assumption. The tapes don't behave like perfect point charges, which can throw off how we see the electric fields and forces. Unequal charge distribution, where the charges on the tapes might not be exactly the same, leading to some inconsistencies in the results. Weight estimation errors. So instead of measuring the weight of the tapes directly, we estimated it, which could affect our force calculations. And not all forces were considered, like air resistance. So our first topic of discussion is, what if the electrons had a positive charge and protons a negative charge? What would change about the observations you made about your tapes and other charged objects? And mostly the observation would have been the same, as the interactions would be the same even with the signs of the charges switching. Since opposite charges will attract and the same charges will still repel. Second, why is it important to handle the charged tapes as little as possible? And what happens when the charged tapes come into contact with hands or other objects? So the reason why it's important is because we need to maintain their charge, and by touching other neutral objects, they may begin to neutralize themselves.